Hey, what is up, the people? On the bench right now, I've got this Sapphire 8 gigabyte R9 390 GPU that is not working. And I don't desperately need it to get it working, but if I can get it working, I can put it to use. So we're going to take a look at it today, see if I can possibly get it running again. And unfortunately, I can't show you what it's doing for two reasons. One, it doesn't do anything. Like you power up a PC that it's in or whatever, the fans don't spin. There's no video output. It's just sitting there dead. And then two, I've already kind of opened it up and took a little look around there and see if I could maybe figure out what was wrong. And I think I've identified at least a couple issues. Hopefully those are the only two issues. And if we rectify those, the card will work again. But I guess we'll find out shortly. Now, I haven't really done like a whole lot of investigation, but what I have done is let's go ahead and remove the heatsink here because we don't need that in the way. I took off the heatsink and I kind of sort of did like a quick inspection of the board and took a look around. And, the first area I sort of suspected was like maybe here because this is where the power comes in for like the most of, the GPU core and all the main components and everything, the memory and all that stuff. So I thought, take a look around. Let's go ahead and zoom in, see if anything looks obviously, like burnt or fried or something. If we take a look right here, we see we've got a couple fuses that are marked Q. We've got a couple fuses here that are marked R. And so, kind of looked around this area here. This would probably be like, like the controller for all this stuff. Seeing if anything looks like charred or if there's any holes in any of these power components. So then, seeing that nothing was like obvious, I got out the multimeter and let's go ahead and bring that up here on the left side of the screen. There it is. I checked continuity on these fuses and that's fine. We see that one's fine. That one's okay. This one's okay. So nothing obvious there, but I went ahead and checked, like pretty much everything on the board. And then we have this other one down here. Check this out. Nothing. And this is working. Go back to here. Nothing. And if we check this side of the fuse over to these pins right here, we see that we are getting continuity from there to there. And if we take a look real quick over here, if we take a look at this chart right here, side B is the top side of the board. Side A is the bottom side of the board. We can see that the first three pins are 12 volt. So the 12 volt coming into the board in here going to that fuse is where we are losing power into the rest of the circuitry there. So yeah, you can see here, good. Here to here, no good. But now what would cause this fuse to blow? That's where I kind of started tracing to, try to see where it went. And I discovered that from this point here, it actually goes up to this MOSFET up here. And which one is it? Right there. It's going to be that one. And again, the multimeter is not updating on the screen. That's annoying. There it is. Okay, we can see that from there to there, we're getting like pretty much full continuity. Okay, so now what is this component? Okay, so this is the data sheet for it. It's an IR3553. It says it's a 40 amp integrated power IR stage. And so this is the basic application for it. So it's like a buck converter here to lower the voltage coming in. And we can see here we've got the pin out. And since we could see it on the board there, we can tell that the way it's laid out right here pretty much matches with what's on here on this little pin diagram. So this is our ground down here. This is our voltage in, and we saw that this one went connected directly to that fuse. And then down here it says T ground. I'm guessing that's going to be like a thermal ground, probably for keeping some heat sinking on the component there. And then right here it says SW. So this SW portion here goes to is like the switched output. So we can see that internally there's some MOSFETs that go from like VN to the output there, and also from the power ground, to there. So it's basically switching these back and forth really fast. So there should be no continuity between the VN pin and the output, or the switched output here, and there should be no continuity between the ground here and the switched output under normal circumstances. But let's see what we actually have on the board. So I'm going to put the ground right here, and I'm going to put the positive here on the VN pin or contacts. And we have, it says about 36.8 ohms or so. So now let's check from the P ground over to the switched output, which is down at the bottom down here. Let me go ahead and contact that. And we see we also have about, it says also about 36 ohms. So not entirely sure what's all that's going through, but I mean, that seems pretty low either way. So I'm going to remove this power device, and they actually already have replacements. I ordered these. I ended up getting them off of eBay, so I'm hoping they're legit. They came shipped from China, which is something that I've mentioned before. I usually don't like to do with components like these, but that was pretty much the only place I could find these, and so I've got them. And I mean, they look legit, but I'm not 100% for sure. So we'll see if one of these takes care of the problem. But we still need to replace the fuse, and I've actually got that right here. We see it's a fuse. It turns out that this is an 8 amp fuse, 125 volts AC, 125 volt DC. And if you look right here, I ordered these on the 10th of July of 2022. So they've been sitting around for almost a year at this point. Okay, so let's go ahead and try to remove this. I just realized it's supposed to be power stage on the data sheet there, and I said, what is it, power IR stage? Yeah, power stage. So putting some flux on it first, just to make it easier. And then as usual with this type of stuff, we're going to be using hot air. And I actually have the board sitting here on the infrared preheating plate, because I want the board to be warm enough to not suck so much heat out of the air, basically. And it just makes it easier, so it should help. And here we go. Let's go ahead and start heating this up. And I'm hoping that flux kind of flows underneath there. Man, thick boards like this always demand a lot of heat, so I put a bit more flux on there. And it turned up the heat some. Let's see if we can get it off now. Man, I am really having a hard time with this. I think maybe I just need to invest in a better hot air station, because it's struggling. I'm trying not to break the component because I want to test it off the board. I'm still going to replace it anyways, but I just want to, check and see if what we measured on the board is the same off the board, with the component off the board, as it was on the board. So, all right, put on slightly bigger nozzle. See if maybe that helps. There we go. I can see it getting liquid. Come on, we can do it. We can do it. There we go. Not saying that was a pain, but yeah, that sucked. Well, dang it. I forgot to hit record when I was pulling the fuse out as well, but I've already got the fuse out, and I put some regular leaded flux here, or not flux, but solder, to try to soften things up a bit, because the solder that they used is like a very high temperature solder, and it's, man, I'm even struggling with this. See how it solidifies before I even remove the soldering iron? And that's what the board heated. If this board was not heated, I'd be struggling like crazy. Well, that's not to say I'm not struggling, because I am struggling, but it'd be even worse. One of my biggest struggles is remembering to hit record after I pause the recording for a while there. But I've changed the tip to a much bigger tip, and hopefully that should, the amount of heat, oh yeah, that's helping a lot. I think the tip I had on there was also way too small, so it was losing heat very fast. This bigger tip is working pretty well. So there we go. The fuse contacts are clean, and I'm also going to apply some solder here to these so I can clean them up. Try not to lose any of those capacitors in the process. I should put more flux on that area. Now this top row and the very bottom row only gets used up to a certain extent, and then the rest is just kind of there. So I'm going to try to pull some of this solder off to the side. And then see if I can clean off the rest. And again, this braid is sticking. It's just, man, I really dislike working on boards this thick. It's stuck and I can't melt it off again. Oh, come on. Remember that pad that I'm on there right now, that was one of the, it's like the thermal ground. So that's going to be connected to the rest of the copper on the board. Man, and there I was thinking 10 minutes tops, in and out. Shall be right. Nope. This is a pain. Normally I don't go sideways like this, but I'm trying not to touch the other ones. Okay. That looks okay-ish. IPA soaked swab. Let's clean this up a bit. Ah, dang it. I still have like a bit of a bubble right there. I want to remove most of that so the new component can hopefully sit as flush as possible. Okay, got that. There's a tiny bit right here that I should probably get. And there we go. Okay, so that looks pretty good, and no torn pads. So I think we are okay so far. Before I move away from this scene here, let's go ahead and check and see what sort of resistance values we get now. So once again, I'm going to put the negative probe on the power ground there and on the output. And now it's just wide open, so that seems pretty good. Let's check from here to here. And wow, 4.3. I mean, that's kind of weird. I don't know if that should be normal, if there's some sort of like a resistor between those 2 points or what, but we saw that when we first measured it on the board, it was only like 36 ohms, not down to 4. Well, let's check the actual component itself and see what kind of readings we get on that. Okay, so I flipped it here so that we could fit it into the display area. So this was the power ground. So it's there, and let's hook this up to here. And now I'm getting nothing. See, that's working there, but nothing there. That's obviously ground, so that's fine. And to the switched output, nothing. So now without this in the board, I'm getting totally different results. I don't know what to think about that. Unless heating up the component removed whatever short was in there. I'm assuming this thing must have been shorted or something. So here's a brand spanking new one. Let's see what kind of results we get from this one. So power ground and V in, nothing. Power ground to switched output, nothing. Switched output to V in, nothing. And this way, nothing. I forgot to check it in that direction on the old one. Let's go ahead and try it real quick. Move this out of the way. It's from the switched output. Oh. Oh. Look at that. Shorted between the input and the output. Well, that gives us some hope. Because this one definitely does not do that. I thought it'd be interesting to take a quick look at both of the components, the replacement component as well as the original component, to see if there's any obvious differences and maybe something that would indicate that perhaps the new replacements were fake chips. But taking a look at it here, you can see I've got the original one on the left. I've got the new one on the right. Both of these, the text has been like laser etched into it. And it all looks like fairly well aligned. Like we don't have this for like say like the new one, like shifted either up or down or left or right or anything like that. They look about pretty even, and the depth of the engravement actually kind of appears to be about the same. You can see when I tilt that there, that was a new part. This is the old part. It seems to be about the same. And another thing here that we can actually notice that I don't know if it's on purpose or not, but on the old part, if I take it here, you can kind of tell when I tilt it up. Look at that 5 on the next to the first 3 on the left. It looks to be like slightly misaligned. And this is the old part. You can tell because, well, it's going to be kind of difficult here, but see all the old solder on there? So yeah, that 5 looks like it's, I don't know, kind of wonky there. It's not exactly lined up with the rest of the text. And on the new one, it actually appears to be about the same. See how it's not quite lined up with everything else? Like there's a slight misalignment there. So I don't know if that that means that they were printed by like the same machine or that's intentional or what, but yeah, that's just kind of interesting. The rest of the characters and stuff like that C318P and the GTZZ, like those are obviously different on both of these. Also, you can tell that the 5, the right next to that C there, that C510P, the 5 is also slightly misaligned, but there's no 5 on this one. It's a 3, and that one looks pretty aligned with the rest of the text. So honestly, don't know if that means anything, but basically there's nothing. Oops, there's nothing on here that makes me suspect that these new components are counterfeits or rebatched parts or anything, because other than like where I ordered them from, there's just nothing to indicate that there's anything wrong with them. So hopefully we got legit pieces and this is going to work. Okay, so I'm going to use this pencil here with a very sharp chisel tip to try to apply solder to the very tiny pads that are up there on this on the pads. That should hopefully help the new component make good contact where it should. Doesn't help that I'm basically working in this little tiny valley between two inductors, and I have to have the soldering iron sticking out of the side here on the right. Now I've got a bunch of solder down here too, and that's, you see that? There's so much copper there that I put the soldering iron on that pad and it sticks. I'm gonna have to raise the temperature on the little pencil here. I'm also gonna raise the temperature on the, oh, that's a little too high, on the infrared preheater plate here a bit too, because let's see, I'll try to set it to about 120 degrees C. And then the other problem is I can't bring the solder in through the side unless I maybe stick it in through one of these vents, because the back plate is in my way. There we go. I think maybe now the board's finally hot enough to let this flow a little easier. Still struggling a bit, but it seems to be working a little bit better. Okay, we'll try to make do with that. See how it goes. Now I'm going to reapply some more flux here and bring in the new component. And that'll go in there, something like that. See if it at least stuck down a little bit, if I can let it go. Nope. Heat it some more. Ah. Sort of. Let me just try some heat first, and it's not going very well. Whoa, 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 whoa. That was cool. Let's see. Gonna remove some heat, let it solidify a little bit, and then I'm gonna try pushing down and applying some more heat. Okay, here we go. This thing is freaking hot, and I can't put my can't rest my forearm anywhere. Let's see, right here. Give me some leverage. Okay, let's try that. Here we go. Nice, nice. That seems pretty good. Is it all the way down though? I'm not sure. Okay. Let it go. Release it. It's very hard to tell. But what I'll do is I'll try running the pencil here along the edges and hoping that I'll get good contact on all those sides. Okay, I think that one looks okay. I am going to give it a good manual inspection, though, before I even try to power it up, just to make sure. But it looks like it went on mostly all right. Now the fuse, now this should be stupid easy compared to that MOSFET or power, whatever it was. Also going to put just a bit of flux right here too, just to kind of help me out a bit. Okay, so I've got that somewhat aligned there, and I'm going to touch it to that. Okay, bring it in. There we go. And I accidentally touched one of the gold fingers with solder. See that? This one's nothing compared to the other thing. Best as I can tell, it looks like all these contacts are very well soldered on that side. And on the top side, I'm not really seeing any issues either, except for that third one there from the left. I'm not entirely sure what's going on with that. Sprayed some alcohol there so I can maybe kind of see through that. Yeah, no, that looks like it's okay. The rest of these look pretty good. You see it only goes up to there. And then the big heavy traces, I'm not even really worried about those. I'm pretty sure those are okay. The fuse, it's like, well, whatever, as long as it's making good contact there, and I believe it is. Let's go ahead and test it out. So let's check from here to here. Yep, from here to here. Yep, and then from the 12-volt pins coming in to here, we should have continuity. So let's go ahead and check from there and then to there. And that's good. Cool. All right, now let's check from here to here. We saw that that's where the other component was shorted. Let's see what we got. And nothing. All right, looking good so far. From here to here. Huh, that's so weird. We saw that when the board didn't have any component on it, it was only up down to like about 4 point something. And now that the component is on the board, it's up to 22.7. So, no idea what's going on there, but whatever. Let's check from here to here. Nothing. And before we were getting about 36 ohms, so let's check from here to here. Nothing. Well, should we try it? I think that's that's the next step. Alrighty now. Next step, clean off all the old paste, put on some new paste, and put the heatsink back on the board. All right, it's all back together now. And one thing I didn't notice, and I didn't notice this when I originally took it apart either, but the 4 screws that hold down the GPU area actually have a smaller diameter threads, or like they're thinner than the ones that go like all the other positions. So I kept like trying, like different screws here and wondering why they didn't thread. I didn't realize until like towards the end that I was like, oh, it's because these are smaller. So yeah, once I figured that out, then it made sense. So I just kind of tightened them until they bottomed out. They all have a small spring on them, so that will keep some pressure on the board there. So I didn't like, tighten the crap out of them, but they are snug enough that they're not just going to, like release by themselves or anything like that. One other thing I want to do before I actually attempt to power up the board is I want to clean the edge connector here, all these fingers. And you can actually, if you pay attention right there to that one finger, you can see where it looks a little bit silver right there. That's where I accidentally touched the soldering iron when I was soldering the fuse in there. I pulled back and accidentally made contact with there, so it put a tiny little bit of solder there on that finger, but it's going to be okay. I mean, the actual contacts, they come up a little bit higher, so it's not a big deal. But in order to clean this, there's actually this little trick that I learned from a computer repair teacher I had back in high school many years ago. And what she taught us is to use an eraser like this, a pink eraser, because it's slightly abrasive, but it's not going to be damaging like, sandpaper or something else like that would. And it actually does a really good job. Just kind of like erase basically all the grime and stuff that's on the contacts just by going back and forth there. That little tiny bit of abrasiveness is going to do a pretty good job of cleaning up all those contacts. And this is a method that I've been using for, I mean, basically decades now, like a couple decades, and it always works really well. It might be kind of hard to get it on camera there, but I don't know if you can tell how clean those contacts look. I guess I should have gotten like a good close-up. Actually, I can still do it on the other side. I'll get a good close-up of what they look like before and what they look like after running the eraser over them. So after I do that, I mean, obviously you can tell that there's like a little bit of debris left over. What I'll do is I'll take like a Q-tip and I'll put some alcohol on it, and then I'll just kind of wipe them clean. And after that, they're like completely spotless. I've had this method like help me solve like RAM issues a bunch of times. Like when the computer starts crapping out for whatever reason, you start getting like random errors. Sometimes just cleaning the RAM, like all the contacts on it, like using this method, pop everything back in, like makes everything flawless. So just a little tip there I thought I would share. All right, I'm going to try my best not to move the card while I'm erasing these contacts, but that's about as close as I can get it there with the microscope. And because everything's like so reflective and shiny, it's really hard to see. If I cover it up a little bit like this, you might be able to see there those contacts. So now I'm going to run the eraser over them, and we'll see what kind of difference it makes to those contacts. Okay, let's just brush off some of these little bits of debris. And already you can tell that it got rid of some of those dark areas. There's a tiny little bit like on that one right there. You can see it. But for the most part, let's see. There you go. Like there's material there that's kind of engraved from where the fingers inside the connector like rub up on it. But they should definitely be much cleaner. And there should be no problems with the contacts. Now the main reason I wanted to clean these off is just to eliminate another potential source of like problems or boot up issues like on the first try, because this board has been sitting around, like I said, it's been over a year now. So we just give it a chance. Increase the odds that it's going to work on the first try. All right, moment of truth here. So I have this motherboard here set up. There's actually an M.2 SSD down in here that I've installed Windows 10 on already. There's no graphics drivers or anything. I actually just used this crappy little 1030 to install it. So no graphics drivers have been installed. And this is a Ryzen 7 2700 that I put in here that actually came out of my PC before I upgraded it. I got 16 gigs of RAM. This Corsair CX750 power supply powering everything. And then this crappy little Acer monitor here that we're going to use to see if it comes up. And I was originally thinking about just hooking the HDMI here straight up into my capture device, but I kind of want to eliminate having any issues and having to do like, any guesswork as to why stuff isn't displaying. So I figured the best thing to do was to have a direct connection from the board into a monitor, and that way, we have like no problems. The only thing is that this display only has a DVI and the 15-pin VGA input. So I'm going to use this cable here that goes from DisplayPort to DVI, and I could have used a DVI to DVI, but the only problem is the cables that I do have are all kind of like thick and chunky, and I wanted to use this one because this one's like really thin and flexible, and that way it'll avoid you putting like extra like strain on the board here or whatever, like, you know, making it want to go side to side or whatever. So I'm going to go ahead and connect this cable here to the back of the monitor. And I don't have the switch on the power supply on just yet. I'm actually going to do that in like the last minute. So, and just so people can see that I'm not trying to pull a fast one here, you can see that the fuse there has my blobby bit of soldering, and then you can also see the little bit of solder right there on the gold fingers. So that's going to pop into here. That should be locked in. Let's and this is kind of want to do this all in one shot, but kind of having trouble doing everything with one hand. I'll probably just speed this part up just to make it faster. Okay, that's both power cables connected, and it would have been much easier if either the card would have only been the 6 pins per connector, or these connectors had already had the 8, but they're the type that's the split, the 2 grounds and then the rest of the 6 conductors. So there's the card in place. I don't like how this kind of leans to the right like that, but I think I'm gonna have to make do. Hopefully it doesn't affect the contact on the connector there. Now I need to bring this up here. Okay, plug that into the display port, and everything's connected. Let's see what happens. I'm just gonna set this down. That, because I do want to use my 2 hands now. If something goes catastrophically wrong, I want to be able to quickly unplug things. So here we go. Hitting the switch there. So now the board technically has standby power. Here we go. And I got to short these 2 pins down here for this thing to power up. So let's see what happens. Here we go. Okay, the fans are not spinning, but they don't necessarily have to spin if the card's not warm or anything. And nothing on the display. That doesn't well, that kind of sucks. Let's see, it's powered off. I'll try repositioning the card a little bit. Oh, you saw them tick just now, but I mean, it would have been good if it would have happened when we first powered it up. Kind of want it to sit like up a little more this way, but I don't want to hold it because I don't want to accidentally let it go and then have it tilt over. So maybe I'll put something down here. Hey, this eraser will do. There we go. That works. Okay, here we go again. Let's see. Oops, I didn't touch them. There we go. Oh, I forgot that there's some LEDs up here that I can check and see what's going on. So right now we've got the boot and the VGA LEDs lit up. Usually when the VGA LED is lit up, it means that the graphics are not working. Well, the people, unfortunately, it didn't work. So you can tell that this PC is working, though. I put in the 1030 back into here, and you can see that it has booted. So it's not that. So unless I can figure out, you know, what else might be wrong with this card, I think it's a goner for now. So, oh, I guess that's going to do it for that one. Oh man, the people, I'm so mad at myself right now because I completely forgot, and I've actually already removed the heatsink again, but let me flip this over. Anyways, I completely forgot that I was also going to replace this 5-volt regulator on the board down here. And as I mentioned, it's been over a year since I initially even found the problems for this, so I completely forgot about that part. But that 5-volt regulator right there is definitely suspect. And the only thing that reminded me of it is that I decided to go online and type in R9 390 or I don't know, Sapphire. So I typed in something about this card, and then I put in like, IR35 or 53, and then I came across a Reddit post where actually people were talking about that. This regulator, the fuse, and the that power switch device that I replaced in there. All three of those should have gone, and then that's what reminded me. I was like, "Dang it, the freaking 5-volt regulator! I was gonna do that too." So it could have worked on the first try, but at least that kind of gives us some hope that maybe it's not completely dead. But if we take a look here real quick, I don't have this hooked up to the PC, so I'm not going to show it on the screen. But the fuse blew again, and if we check the switched output on the power switch there, and the input, we see that it's shorted once again. So, as much as it pains me to try again, for the sake of the video here, I'm going to try to, well, I mean, I'm going to replace that again because I still have a bunch left over. And I don't know, this package came with what, like 10 of them or something, I think. So I still got 9 left. And we're also going to replace the fuse because that's gone. And then I got to find the 5-volt regulator. I know I at least had one around here. I don't remember if I ordered more, to be honest, but if I did, I should be able to find them. I haven't actually looked for them yet. So give me a second, and I'll come back with everything. So unfortunately, it appears that I did not order any more of these 78 MO5s, and that's probably part of the reason why I completely forgot that I was even going to replace it in the first place. However, looking through my little bins of regulators and stuff, I did find a 7805 in the same package style. And the only difference between the 78M05 and a straight up 7805 is that the 7805 is a 1 amp rated part, and the M05s are 500 milliamp rated parts. So the new one is technically should be capable of handling more current than the original, which is the only difference between the two. So swapping this out for this one should be totally fine. Let's just verify that this component is indeed functional, since it's in my little bins of parts here. So I've got the negative connected to the tab, and I've got about 12 volts coming into here. So there we go. We see 11.9 right there on the top left corner. And now if I move this over to the other side, and I'm trying to be careful because I'm holding these two test leads like chopsticks, we'll touch it to there, and I'm not making very good contact. There we go, right there. So yep, right about 5 volts. So this component is functional. Okay, so here we are again. So I've got the new switcher, I've got a new fuse, and now we also have a replacement 5-volt regulator. Now this time I also removed the back plate here from the card to make it easier to get into the where the little switcher is there. As you can see, it's just kind of like a little valley between those two inductors, that one and that capacitor right there. So it makes it very difficult to work in there, and I had to like come in with the solder here on the side, and so it was all kind of a pain. So I'm not going to do a whole lot of explanation this time as to what's going on. I'm just going to replace these components as quickly as possible and making sure that they are properly soldered in place. And then I'm going to flip the board over, replace the 5-volt regulator, and after that I'll repaste the GPU, and hopefully it'll work this time. For some reason, I always seem to forget to hit record every time I replace this fuse, but there's a new one. So everything else looks all right in this area, minus this little tiny chip that I broke right here, but it shouldn't affect anything. The last thing to replace is this 5-volt regulator, and it should hopefully be pretty quick, but I guess we'll find out. Okay, that's done. That was such a much smoother process than the other one. Well, the peoples, I'll spare you the torture. It didn't work. So the funny thing is, though, that this time the fuse didn't blow. I can actually check it from the bottom there just to check resistance. So I don't know if there's something wrong with the actual the GPU die or what. But unfortunately, I don't have some of the equipment I would need to test this off the board, or not on the motherboard, and so that I could set it down right here on the bench or something, and probe around to check voltages and stuff. but I've probably already spent more time and money than it's worth. This is an older card, and unfortunately, it's not like I deal with these kinds of things all the time. I'm just a lone fool here in my garage, just messing with whatever I happen to come across or want to look at. So, well, I thought I'd give it a chance. And other thing is that I also checked the 5-volt regulator, the one that was on the board there, and you can see there it's oh, if it would focus. Anyways, that's a 78 MO5. I tested it off the board, and it does appear to function properly. So it doesn't seem that that was the issue either. Now, one other thing is that I was, I, you saw that I struggled to pull those components off the board there with the heat. So I don't know if there's something up with my hot air station that it's just not delivering enough heat or something, because I saw some other videos of people that were also fixed up some of these cards and they got off lucky. They were just able to replace that fuse and the power switch, and their cards work fine. But I just happen, my luck, there's something more. There's something else that's bad on this card that I just haven't found, and I don't really want to invest too much more time in. But yeah, I saw one guy that he just had his board sitting there on a piece of wood, and he used his hot air station and was able to quickly remove and replace that component. No such luck here, so I don't know. I guess I got to look into that. But well, other than that, that's just gonna have to do it for this one.